And hello YouTube, this is GS Smart, and I'm here today with another brand new YouTube tutorial. And today's tutorial, we're going to be teaching you how to do a ChiSquare test with data that you've collected. Now we're going to be using Excel to do this ChiSquare test. Now I'm using 2010. You can use other versions. If you have 2007, you can use that as well. I have my setup like this. You can set up the exact same way, depending on what kind of data you have. If you have numerical data, then it's basically this type of data. You basically have numbers for data. If you have descriptive data, then you basically have words like yes or no, or different colors, or stuff like that, basically not numbers. So depending on what kind of data you have, I'm going to be showing you how to do both types of ChiSquare tests. So if you want to pause the video to set yourself up like this, then you may do so. Be aware that for the ChiSquare test, you do need categories. So you can't just run a ChiSquare test with your data like this. You have to divide your data into categories, and basically your categories should be I like to do mine in a 2x2, but you don't need to have, if you have some experience with ChiSquare tests, then you can probably do more than 2x2, but I like to do mine by a 2x2. So if you like to set it up a 2x2 like this, then you may do so. But if you just want to see how this goes, then just follow along. So basically, I'm going to be showing you how to do the descriptive data first. Now, since we don't have any numbers for our descriptive data, we basically need to make our numbers. So we have an experiment that tests if there's a correlation between gender and if they have a mobile phone or a mobile device. Here we have our results from collecting data. We have males saying yes and no, and females saying yes and no. Now, obviously, I made all this data up, so don't think, this person here has 288 pounds, or, I made this all up. So the first thing you want to do if you have descriptive data like this, you want to count up your totals basically. So I'm going to count my yeses. How many males have a mobile device? 1, 2, 3, 4, 5, 7. So 7 have one, and since I know that there are 12 entries here, 12 minus 7 is 5, so 5 say no. Same with females. 1, 2, 3, 4, 5, 6. 6 say yes, so that means 6 also say no. So now that we have our totals, we can use this to place in our table right here. So if you have descriptive data, it's actually a little easier. If you have numerical data, it's a little more time consuming. So now basically what we're doing is we're splitting up our data into categories. So first you're going to start with your observed values. Now your observed values is your data. This is basically what we collected. It's called observed values because these are the data values we observed in the experiment. So a chi-square test basically measures the difference between observed values and expected values. Now the expected values we need to calculate. We can't find the expected values from our data. So let's fill in our observed values first. First, we need to make categories. And to make categories, we're basically going to make categories. Genders. We're going to type in males, females, yes, no. And let's move this down actually. Sorry about this, I kind of screwed up on the charts here. Alright, so there we go. So I basically separated my table into males who have a mobile device, females who have a mobile device, males who don't have a mobile device, and females who don't have a mobile device. This is basically how you would need to set up your table. Now all we gotta do is copy our data, since we already have our data here. There we go. Males who have one, yes. Males who don't have one, actually didn't work out. So let me just fix this. 6, 6. So instead of copying it like I did, just go ahead and type it in yourself. Now, if you're wondering how I made these borders, these lines that separate the boxes, all you gotta do is highlight your section, click this box right here, and you can select from a different kinds. I use this one, all borders. So now we have our data. How many males have phones? 7. As we can see here, males 7. How many males don't have phones? 5. Don't have phones, 5. How many females have phones? 6. 6 don't have 6. 6. So now that we have our data in our table, we have to find the totals. 7 plus 5 is 12. 6 plus 6 is 12. 7 plus 6 is 13. 5 plus 6 is 11. 13 plus 11 is 24. 12 plus 12 is 24. 24 plus 24 is 48. So you're basically just finding your totals. So now we have our observed values. This is our observed values table. Now what we need to do is find our expected values. So what I'm going to do, I'm just going to copy this data into here. And I'm going to erase my data values for yes and no. Now if you have big numbers, you can just do this method right here. You can just press equal. Now whenever you type in a formula, you start with equal. You can type it in a cell, or you can type it in the formula bar up here. So you press equal, you click your number, shift, click plus, your second number, click enter, and it basically does the math for you. So you have big numbers, you can basically just do it that way, or use a calculator. But small numbers, you can do easy math. So now you paste your data into your expected values table, and you erase your data values for yes and no. Now to find your expected values, you have the formula states this. You need to multiply your column total times the row total for that cell divided by the grand total. So let me show you. You press equal, you take your first number, which is your column total, multiply it. You can press shift 8, give this multiply sign, multiply it times your column total for that cell, divide, division sign, which is the /, divide by your grand total, 48. Click enter, and that is your expected value for that cell. Now for this cell, you click equal again, click your column total, multiply. This time you're going to use this number because it's for that cell. See, it goes over like this. We use this number because it went over like that. So next we're going to use this number divided by your grand total. Same thing over here. Equal, we're going to click our first number, multiply, divide, enter, again equal, times our row and column total, and divide by our grand total. So there we go. Now we have our expected values. These are our expected values. Now to find the chi-square value, which will be the p-value, we need to run the chi-square test. To do that, you press equal, C-H-I-T-E-S-T, chi-test. You can do that once again in the cell here on top of the formula bar. You start your parentheses, and you're basically going to highlight your data values for your observed values. Hit comma, and you're going to highlight your expected values. End parentheses, click enter, and there is your p-value. Now we need to select an alpha level. Basically, there are 3 different kinds of alpha levels. We have 0.01, 0.05, and 0.1. Now, if you're going to use 0.01, you have an experiment with not a lot of error. If you're going to use 0.01, your experiment has a lot of error. If you're not sure if your experiment has a lot or not a lot of error, so if you're not sure on how much error your experiment has, or if you don't really know, you're going to use 0.05. Most experiments use 0.05. So unless you're really sure how much error your experiment has, then you're going to use one of these two numbers. But if you're not sure and you don't know, then just use 0.05, since that is the standard. So 0.05. Now, remember, your chi-squared is testing if there is a significant relationship. So you basically have to compare these numbers. Which number is bigger, the p-value or the alpha level? In this case, your alpha level is bigger. So if we look over here, if the p-value is less than the alpha level, so the p-value is smaller than the alpha level, then we reject the null hypothesis. A null hypothesis states that there is no relationship between genders and having a mobile device. Your regular hypothesis would be that there is a relationship. So since our p-value is less than our alpha level, if the p-value is less than the alpha level, we reject the null hypothesis and we accept the regular hypothesis. So we're rejecting that there is no relationship, which means we're accepting that there is a relationship. So our conclusion would be that there is a relationship because our p-value is smaller than our alpha level. We're basically rejecting our null hypothesis. Now, this is how you do a chi-square test using this type of data, using descriptive data. Now, for numerical data, it gets a little more complicated because you need to do the exact same thing. You split your data into categories, like we did here: males, females, yes and no. But since we have different numbers here, now you're going to have to make your own categories. So what I like to do is find the middle age here. Basically find the range. Our highest age here is our highest age here is 38. Our lowest age here is 10. So 38 minus 10 is 18. So I'm going to use age here. I'm going to use below 18, and I'm going to use 18 plus for one of the categories. Now for the second categories, we're basically comparing height. Well, not height, is age. Age to weight. Age to weight. So we're testing if there's a relationship between age and weight. So once again, we need to make our categories. So our first category for age is below 18 and 18 plus. Now for our weight, we need to find a reasonable weight. So once again, what I like to do is do the range. Our highest is 288 and our lowest is 98. So equals 288 minus 98 equals 190. So here we can put below 190, and here we can put 190 plus. So now we have our categories. This is for our ages, and this is for our weight. This is for our weight, and this is for our age. So now basically what you have to do is fill in the blanks here. So how many people that are under 18 are more than 190 pounds? Now that we have our categories filled up as so, now we can start filling in our spaces here. Now these will be our data value spaces. Now because we don't have, since we don't have it as easy as this, we're going to have to count, and this may take some time. So we're looking for ages below 18. So what I'm going to do is I'm going to color code this. I'm going to make this yellow. And what I'm going to do is I'm going to highlight all the below 18s. Any other ones? No. Okay. Now we're looking for below 190 pounds. Oops. below 190 pounds, which would be just one, I think. Yeah, just this one. Okay, so that's it. We just have one. Now remember, all this data is made up, so it's not really accurate even. So now we go below 18 who are above 190, which were these two right here. And I'm going to make this green. I accidentally made this red. Okay, so we're going to make this green, and that was 2. That's 2. Now we're going to do 18 plus that are below 90. So all these are 18 or above, and below 190, here's one. We're going to make this red. Here's another. Here's another. Here's another. Here's another. And these two. So that's 1, 2, 3, 4, 5, 6, 7. That's 7. And then, once again, you can color code this. And then over here, we'll use blue, which would obviously be these two. Now we add these up. 1 plus 7 is 8. 2 plus 2 is 4. 1 plus 2 is 3. 7 plus 2 is 9. And our grand total will be 9 plus 3 is 12. Plus 8 is 20. Plus 4 is 24. 24. So now that we have our table, just like over here, we have our table set up. Now I'm going to do the exact same thing. I'm going to copy this and paste it down here. I actually think I screwed up there. Yeah, I did screw up there. Okay, let me try this again. Let's copy this and paste it like that. There we go. And the same thing, we're going to erase our data values here. And now you do the same technique that we did over here. You go equal, click our first number, multiply by that second number, divide by that, click enter. Same thing here, equals, gonna click that number, multiply by that number, divided by that number, equals. Same thing over here, equals that number times that number divided by that number, equals, and then that number times that number divided by that number, equals. So now we have our expected values. Here are observed values, here are expected values. Do the same thing here. We're going to look for our P, and we're going to go over here and you type in equals ChiTest, ChiTest, parentheses, get your observed data, comma, get your expected data, end parentheses, and your p-value is here. For your alpha level, once again, we're using 0.05, and in this case, the p-value is once again less than the alpha level, so our result would be that there is a relationship. Now, obviously, we don't have a lot of data. You usually do chi-square tests when you have lots of data. So this was just an example, but that is exactly how you do a chi-square test in Excel. Very simple, actually, just very time-consuming. But that's basically it. Thank you all for watching, and this is GS Man Smart, and I'll be back sooner than you think. Don't go anywhere.